recorded. Okay, so we will start. So good morning all. So before starting, just give me reply whether my voice is properly audible and my screen is visible. Please reply anyone.
Yes,
Yes,
sir.
sir.
Okay.
Screen is not visible, sir.
Screen is not visible. So you have to pin my screen. Whatever screen I have shared, no, you have to make pin. There is one option is there. So my two screens will be there. On one I am talking. On another I have shared my screen. So please check
Okay, sir,
that
visible.
shared screen in your participant list and you have to pin it. So I request all the students. So from my side, there will be the two screens. On one, I am talking. On another, I have shared my screen. And whatever the screen I have shared, you have to pin it. So by mistake, okay, visible. So those who have not visible, please pin it. So you can see that particular screen throughout the lecture without any disturbance. Okay. Okay. So in between, if the voice is breaking due to some network problem, please immediately send the message in the chat box. So I will clear the things at that time only. Okay. So we will start. So once again, good morning all. And once again, I welcome to this online lectures of your direct secondary engineering in the Department of Mechanical Engineering. So yesterday we have started our lectures, especially is basically from the basic things related to our subject. So in the last lecture, we have discussed all the important things, whatever we are going to do in the upcoming semester, that all the basic things, some important things related to do another subject, our subject we have discussed. So I think for the today's lecture, maybe some new students are there. So for them, just I want to repeat a few of the things that we have started the lectures. Now I request all those students, so don't remain absent. If you remain absent, you will miss that particular part, and afterwards it is very difficult to understood. So the lectures will be conducted as per the timetable. There may be repetition sometimes for the new students, so lecture will be conducted as per the timetable, no problem. But sometimes due to some technical problems, some important issues, so another lecture will be conducted. And now you have to prepare the notebook for all the 5 subjects, because during the lecture, whatever the screen is shared by the respective faculty members, through that particular screen, or whatever the content is presented into that particular PPT, so you can prepare your own notes. So it will be better for your understanding. So basically, maximum focus we have to give on the numericals. I am talking for our subject. Maximum focus we have to give on numericals only. So whenever numerical I am presented in front of you, so if it is possible to you, you can solve in your notebook. You can give the solution and you can send their answers in the chat box. I will give the solutions, no problem. But once the 2 or 3 samples problem I will solve, afterwards I will give the problems for your practice. So you have to solve that particular problem. So you have to prepare the separate notebook, because now the online lectures are there, but after sometimes, or maybe after 10, 15 days, if the classes will be start physically, so same notebook you can continue for attending the lectures. And don't remain absent, because whatever your attendance is there, that attendance will be considered for your final term work. So don't remain absent. Any genuine reason is there, you can call to your CC, inform them in advance, and they remain absent. Okay. So for the new students, those who have joined today, so yesterday we have started with this particular online lectures. Yesterday only we have discussed about the importance of our subject, and what is the basic difference between the strength of material and the mechanics of material, because you have studied this particular SOM in your diploma second year, maybe I think semester number 1. Similarly, at the degree side, again this subject is there for the second year, semester number 1, but the name was somewhat different. The name will be given mechanics of material. Okay. So in the yesterday's lecture, we have discussed about the teaching scheme and the examination scheme. What will be the marking scheme is there, that we have discussed in the last lecture, that is 8 semester examination test will be there, term work will be there. Then what will be your internal submission? There is no any external oral for the subject. only internal submission will be there. And important thing is that yesterday we have discussed about the syllabus. So whatever the university syllabus is there, that syllabus we have discussed in the last lecture. So total 8 chapters we have to study in the section number 1. 4 chapters are there. In section number 2, the 4 chapters are there. So in the last lecture or yesterday, we have discussed all the basic things. That means in each and every chapter, which part we have to study, which theoretical part is important, which numerical part is important, what is the basic meaning of that particular title of that particular chapter, on which type or on which particular content we have to focus on the numericals, we have to focus on the theoretical parts. That parts we have discussed in the last lecture only. So the screen is in front of you. This is the section number 1. We have discussed about the principal stresses, strain, then what is meant by the strain energy, what is meant by the impact load, that we have discussed in the last lecture. Then principal stresses, why we have to calculate the principal stresses, and what is its requirement, that we have discussed in the last lecture. What is the basic use of that particular Morse circle, or what is the graphical method, that basic things, important things only we have discussed, where we will start that particular chapter. During teaching again in detail, we will discuss all the that syllabus thoroughly. Then for chapter torsion of the circular shaft, why this particular chapter is very important, which are the parameters we have to calculate, that we have discussed. Then just a minute. Then the chapter number 5, if you go through this particular second section, all the 4 chapters are related to the only one type of element, that is a beam. That beam may be civil structure, that may be the mechanical structure, but all the 4 chapters are correlated with the beams. That is, the first chapter is related to the SFD and BMD. So in this particular section, maximum focus we have to give on the basic behavior of the beam, because what happened, the beam is subjected to the number of loading simultaneously. Means simultaneously point load is acted, UDL is acted, UVL is acted, couple is acted. So due to that number of loads are applied simultaneously, the basic nature of that particular beam, it will get changed. And if we have to check its nature, so we have to study this particular first chapter, that is SFD and BMD. At the same time, as the beam is subjected to the any type of force, that force may be bending force, that force may be the shear force. So stresses are obviously induced. So we have to calculate the bending stresses as well as shear stresses. So these 2 chapters are included in your syllabus. And last chapter we have discussed about slope and deflection. So if we have to calculate the total deflection value from start point to the end point, because what happened after the application of load, the bending of the beam is taking place in the downward direction, because load is applied from the top side, and due to that the bending of the beam is taking place from the downward side. And that moments we have to calculate. So that moments are calculated in the form of deflection, that is the distance between the top point to the bottom point. So that distance will be considered as a deflection, and whatever the slope we have to calculate, that slope we have to calculate in the form of angle. So yesterday I have represented one diagram how the slope will be calculated at the corner side, and how the deflection will be calculated at the different position, that we have discussed in this particular slope and deflection, and in detail again we have to discuss it. Okay, so these are the basic things, the basic syllabus part we have discussed in the last lecture. Now whatever the subject is there, mechanics of material is there, or strength of material is there, or analysis of mechanical element is there, why this particular subject we have to study? So that things also we have to understand, and why these particular chapters are introduced in your syllabus. Now if you go through this particular title of your subject, initially I will go through the title of our basic subject, that is whatever you have studied already, strength of material. Now if you go word by word, that is strength. So what is meant by the strength? Simple definition is there. Strength is the ability of material to resist the applied forces or to resist the deformation. The 2 words are very important: to resist the applied forces or to resist the deformation. So what happens if any body, any mechanical element, any structure, if it is subjected to any external load, at that time its deformation is taking place. So if load is applied, obviously deformation is taking place. But What is our requirement? We have to resist that deformation, or we have to resist that particular applied load. So what happen? Some of the components are there. If that component is subjected to the external load, immediately it will get break. If immediately it will get break, it is not possible to use that particular component for further application. बघा, एखादा component जर आपण लोड अप्लाय केला आणि तो लोड अप्लाय केल्यामुळे लगेच तो कॉम्पोनंटचं डिफॉर्मेशन होत असेल किंवा लगेच तो कॉम्पोनंट जर ब्रेक होत असेल, तर त्या कॉम्पोनंटचा आपल्याला पुढच्या ऍप्लिकेशनसाठी काहीच उपयोग करता येणार नाही. वाय? बिकॉज ड्यू टू द एक्सटर्नल फोर्स, immediately deformation of body is taking place and that component will get break. So what is our requirement? That material should be strong, or it should have maximum strength. Means if it is having the maximum strength, that body can resist the deformation, or that body can resist the applied forces. बघा, एखाद्या बॉडीवर जर आपण फोर्स अप्लाय केला आणि तो अप्लाय झालेला फोर्स जर त्या बॉडीने पूर्णपणे रेजिस्ट केला म्हणजे काय झाला, त्या बॉडीचं कुठल्याच प्रकारचं डिफॉर्मेशन झालं नाही. मग डिफॉर्मेशन झालं नाही म्हणजे आपण काय म्हणू शकतो की दॅट बॉडी हॅज रेजिस्ट दॅट पर्टिक्युलर force. So this is called as a strength. Strength means it is the ability of material to resist the external forces or to resist the deformation. म्हणजे जोपर्यंत आपण त्या बॉडीचं डिफॉर्मेशन अवॉइड करू शकत नाही तोपर्यंत ती बॉडी स्ट्रॉंग आहे किंवा त्या बॉडीची स्ट्रेंथ मॅक्सिमम आहे असं आपण म्हणू शकत नाही. जर त्या बॉडीनं तो पूर्णपणे फोर्स रेजिस्ट केला, विथस्टँड केला, बॉडी ब्रेकच झाली नाही, बॉडीचं डिफॉर्मेशनच झालं नाही, तर आपण सांगू शकतो की that particular body is having the maximum strength. And this particular testing we have to carry out in each and every industry. So what is the basic function? If any industry, if he is manufacturing any type of component, let's take example of automobile. In the automobile, if you take the example of axle, which is important part in the vehicle, maybe front axle or the rear axle. So the axle is one of the rotating element. If vehicle is started, the axle is going to axle is rotated. Maybe the power is coming from the engine. Then that propeller shaft is there. Then that drive is there, and the shaft is start rotating, and the vehicle is moving in forward direction or backward direction. So that axle plays very important role to transmit the motion. But if any company is manufacturing or developing any type of axle and without any testing, if it is used as it is, then without any testing, if it is used as it is, and if that axle will get failed, then we can say that the axle is not strong. So that axle is not withstand any type of load, immediately it is breaking, or the axle is creating problem or maximum torque is developing. So in order to avoid such types of the difficulties, initially what we have to do? Initially we have to manufacture that particular axle. Initially we have to conduct the number of testing. We have to conduct the number of testing on that particular axle, and if that axle will give the feasible result, if it is give the good result, then and then only we can use that particular axle in that particular vehicle. If immediately axle is failing, so it is not possible to use that particular axle in any type of vehicle. So such type of testing we have to do in the industry, and this particular process is called as a checking the strength of material. So if you go through this particular wording, strength, it is the ability of material to resist the external force or to resist the deformation. This is the one part. Material in the sense we can take any component. So in the vehicle, so many components are there. Just now I have given the example. For example, axle is there, then propeller shaft is there, then your gear drive is there, then your vehicle, your that steering system is there. This is the automobile parts. If you take the example of machines, in the machines, so many components are there. Moving components are there, rotating components are there. Some components are moving in upward direction, downward direction. These components are there. Then if you take the example of another so many applications, like if you take the example of civil structure, maybe the beam is there. In that particular beam also, so whatever the civil structures are there, in that particular civil structure, the horizontal structure is called as a beam, vertical structure is called as a column. So initially, before the building, initially we have to do the calculations. We have to check how much load that building can sustain, and then and then only we can go for the concrete design, or then and then only we can go for the steel design. बघा, आपल्याला एक मजला तयार करायचा असेल तर त्या ठिकाणी आपण लोड कॅल्क्युलेशन केलं असतं की बाबा ह्या बिल्डिंगवर किती लोड येणार आहे. इफ वी हॅव टू इन्क्रीज द नंबर ऑफ बिल्डिंग्स ऑन वन अनदर, एकावर एक, दुसरी, तिसरी, चौथी, if number of buildings are increases at that time, we have to go for the structure design, we have to go for the steel calculation, or we have to design that particular concrete. जर आपण ते डिझाईनच केलं नाही आणि आहेचे जर बिल्डिंग वाढवत गेलो, जसा जसा लोड वाढेल तसं तसं तुमचे खाली क्रॅक्स पडत जाणार, अँड समटाइम्स देर मे बी पॉसिबिलिटी ऑफ दॅट पर्टिक्युलर ब्रेकेज. So in order to avoid the such types of all the difficulties in all the type of elements, it may be mechanical, it may be civil, or it may be any machine structure, automobile structure, any other. So we have to go for the checking the strength of material. Checking the strength of material means which parameter we are calculating. Yesterday we have discussed checking the strength of material means to calculate all the types of stresses, all the types of strain, their deformation, there all the types of forces, maybe shear force, tensile force, compressive force, then there may be calculation of bending stresses, shear stresses, slope and deflection. So if you go through the each and every chapter, in each and every chapter we are calculating one unknown parameter. For example, in the chapter number 1 we are calculating the tensile stresses, compressive stresses, shear stresses, all the elastic constants, that is capital E, capital G, capital K. We are calculating that parameter means we are checking the strength of that particular material. Then second chapter, strain energy. We are calculating the strain energy means we can calculate how much amount of energy is stored in that particular body. The calculation of the strain energy means we are calculating the strength of that particular material. बघा, एखाद्या स्प्रिंग मध्ये आता स्प्रिंग वर किती टेन्साइल फोर्स येतोय, किती शिअर फोर्स येतोय, हे आपल्याला जास्त काढायची गरज नाही. Why? Because the basic function of the spring is to store the energy. स्प्रिंगचं महत्वाचं फंक्शन काय, एनर्जी किती स्टोअर करते. जर त्या स्प्रिंग मध्ये एनर्जी स्टोअर होत नसेल तर ती स्प्रिंग आपल्याला एखाद्या ऍप्लिकेशन मध्ये यूज करून काहीच उपयोग होणार नाही. सो initially we have to check the how much amount of energy that spring can store, means we are checking the strength of that particular spring in the form of strain energy calculation. Similarly, in the third chapter, principal stresses, we are calculating the principal stresses, principal strain by using sigma x, sigma y, sigma z, tau z, like that. Again we are calculating one unknown parameter. Chapter number 4, again we are checking the strength of shaft. आता स्ट्रेंथ ऑफ शाफ्ट आपण चेक करतोय म्हणजे कुठले पॅरामीटर काढतोय, वी आर चेकिंग इट्स टॉर्क or torque developed, we are checking the shear stress developed in the shaft, we are checking theta means angle of twist, शाफ्ट किती अँगल न ट्विस्ट झालाय ते कॅल्क्युलेट करणं म्हणजे आपण काय करतो, त्या शाफ्टची स्ट्रेंथ काढतोय. समटाइम्स वी आर कॅल्क्युलेटिंग द पॉवर ट्रान्समिशन कॅपॅसिटी. एखादा जर शाफ्ट एखाद्या ऍप्लिकेशन मध्ये जर वापरला असेल तर तो किती पॉवर ट्रान्समिट करतोय, हाऊ मच अमाउंट ऑफ पॉवर इट विल गेट ट्रान्समिट. दॅट कॅल्क्युलेशन मीन्स checking the strength of the material. So this is about the chapter number 4, and in the second section obviously we have discussed all the calculation part is related to only one structure, that is beam. In the first or chapter number 5 we are checking the behavior of beam after number of loadings, means we are drawing the shear force diagram, we are drawing the bending moment diagram, and through that particular diagram we can obtain the critical points. We can checking the critical points. मग कुठले critical points? Where shear force is 0, where shear force is maximum, where bending moment is 0, where bending moment is maximum. Checking of all this important point means checking the strength of that particular beam. Similarly, in the chapter number 6 we are calculating bending stresses, we are calculating the shear stresses. In the last chapter we are calculating the slope and deflection. That means in all these particular 4 chapters we are checking the strength of that particular beam in the form of calculation of SF, BM, bending stresses, shear stresses, slope and deflection. So therefore this particular subject is introduced in your syllabus, that is basic strength of material. Strength of material means we have to check the strength of any mechanical component, any civil structure which is used in any type of application. If I will take the example of once again vehicle. For example, one maybe if we take the example of Tata Motors, if Tata Motors is manufacturing any vehicle, directly he is not launching that particular vehicle in the market. So initially, once the vehicle is manufactured, they have to perform number of testings. So maybe in the Aurangabad, one testing unit is there. That vehicle is moving through stones. The vehicle is moving through that particular plain surface. Vehicle is moving through the muds. Vehicle is moving in uneven areas. So first of all, they have to check the performance, whether that vehicle is moving on all the types of surfaces. If it is not moving, there may be problem of skidding. If he is facing some another problems, so again they have to remove all that particular, overcome all that particular issues. Again they have to modify the vehicle. Again they have to perform the testings. If the vehicle will give the proper result, then and then only that will come in the market. Okay, so that's why this testing part is very very important, and that all such types of testings we have to perform in this particular chapters or in this particular subject, that is strength of material. Okay, so this is about the strength of material. Then what is meant by the mechanics of material? Mechanics of material, what is meant by the mechanics? What is meant by the mechanics? The strength of material, mechanics of material, analysis of mechanical element, all the three names are correlated with each other. The analysis of mechanical element, analysis means to find something or to get something. Mechanical elements, as it is straightforward word, is there. So many mechanical elements are there. Maybe lever is there, maybe shaft is there, maybe some another mechanical element is there, vehicle components are there. These all components are comes under the mechanical element. And analysis means to find out the something or to do the something. Analysis of mechanical element means to check the strength of material. That means that AME and SOM, both names are correlated with the each other. Then what is meant by the mechanics of material? Whether it is correlated with our subject SOM or not, that we have to check. The mechanics means it is a branch of science which deals with, here I have written, which deals with study of motion, energy, forces and their effect on the bodies. Mechanics, it is the branch of science which deals with study of motion, energy and force. For example, if you take the example of motion, if you take the example of vehicle, if the vehicle is motion or if the shaft is rotating, what is the effect of that particular rotation on that particular shaft? That calculation we have to do means we have to study the effect of RPM on that particular shaft. For example, initially the shaft is rotating for 100 RPM. We can calculate its shear stress. After some times, RPM is increases from 100 to 200, 200 to 300, up to 500. So if the RPM is increases, what is the effect of that particular RPM on that particular rotating shaft? That calculation means it is called as a mechanics. Then energy, effect of energy. If you take the example of spring once again, if the force is applied on the spring, amount of energy it will get stored. If the force is removed, that spring regain to its original position. That means stored energy it will get released. म्हणजे काय एनर्जी आपण स्टोर केलेली होती ती एनर्जी आपण काय केलेलं आहे, रिलीज केलेलं आहे. मग जर त्या स्प्रिंगवर आपण वेगवेगळे फोर्स आपण अप्लाय केलेले असतील किंवा वेगवेगळ्या एनर्जी जर त्याच्यावर आपण आपले डेव्हलप होत असतील तर त्याचा त्या स्प्रिंगवर काय इफेक्ट होतोय, that calculation means once again mechanics. And last part, that is force. You know that there are so many forces are there. Tensile force is there, compressive force is there, shear force is there. If all the such types of the forces are applied on any type of body, what is the effect of that force on that particular body? That calculation means we have to check, or it is called as a mechanics. बघा, टेन्साइल फोर्स जर अप्लाय झाला असेल, ऑब्विसली टेन्साइल स्ट्रेस आणि टेन्साइल स्ट्रेन इंड्यूस होणार आहे. कॉम्प्रेसिव्ह असेल तर कॉम्प्रेसिव्ह स्ट्रेस, कॉम्प्रेसिव्ह स्ट्रेन. शियर फोर्स जर एखाद्या बॉडीवर जर अप्लाय झालेला असेल तर there may be the shear stresses and the shear strength. That means we are checking the effect of forces on that particular bodies, means it is called as a mechanics. Mechanics, again here same word is there, material. So only one word is different, strength of material, mechanics of material. Strength means we are calculating or we are checking the strength of the material in the form of calculation of so many parameters, stresses, strains, bending stresses, shear stresses, etc. And mechanics is also correlated with that particular subject, that is strength means study of motion, energy, forces and their effect on the बॉडीज. म्हणजे ह्या प्रत्येक मोशनचा, प्रत्येक एनर्जीचा, प्रत्येक फोर्सचा त्या बॉडीवर अप्लाय झाल्यानंतर त्या बॉडीवर त्याचा काय इफेक्ट होतोय ते कॅल्क्युलेट करणं म्हणजेच वी आर चेकिंग द स्ट्रेंथ ऑफ दॅट पर्टिक्युलर मटेरियल. ओके, सो दिस इज द बेसिक डेफिनेशन ऑफ द mechanics of material. So based on this, that applied mechanics, maybe in your first year diploma you have studied this particular subject, applied mechanics. The applied mechanics and the mechanics of material, these two subjects are somewhat correlated with the each other, but there is one basic difference. That difference we will see. Okay, so the definition of material, so need not required to tell. Definition of material, simple definition is there. It is the matter from which something can be made or used for the analysis. If body is not present, if material is not present, then it is not possible to perform the testing. जर bodies नसेल, materials available नसेल, it is not possible to perform the testing. Therefore, it is the matter from which something can be made. बघा, तुम्हाला एखाद्या ऍक्सेलचं अनालिसिस करायचं असेल, व्हेकलच्या ऍक्सेलचं, आणि तुमच्याकडे ऍक्सेलच अवेलेबल नाहीये, so it is not possible to perform the any type of testing. Therefore, it is the matter from which something can be made. If the axle will be given to you, and if we rotate that particular axle for the number of RPM, then and then only you will get the result. Axle नसेल, हवेमध्ये आपण हवेमध्ये नुसतं हे फिरून ते फिरून असं आपण फोर्स अप्लाय करू शकत नाही, किंवा कधीच हवेमध्ये फोर्स अप्लाय करू शकत नाही, किंवा हवेमध्ये स्ट्रेस पण कधीच डेव्हलप होत नाही. तर त्यासाठी we require one body, and that body means it is called as a material, and also it is used for the analysis. बघा, एखाद्या गोष्टीचं तुम्हाला अनालिसिस करायचंय, म्हणजे कुठल्या गोष्टीचं अनालिसिस करायचंय ती गोष्ट जर आपल्याकडे नसेल तर इट इज नॉट पॉसिबल टू परफॉर्म द एनी टाइप ऑफ अनालिसिस. Therefore, this material word is very very important. That is, it is the matter from which something can be made or it is used for the analysis. So this word may be available in terms of strength of material, mechanics of material, and analysis of mechanical elements. That mechanical elements means it will be considered as a material. Okay, so this is about the mechanics of material. Now, strength of material. Now only just now I have given the definition of strength of material. काय बघा, resistance to the deformation or resistance to the applied load without any deformation is called as the strength of material. Both definitions we can accept. Resistance to the deformation means if load is applied, there is no any resistance, there is no any deformation, we can say that strength of material is very very high. Or another definition, resistance to the applied forces without any deformation. एखाद्या बॉडीवर जर आपण फोर्स अप्लाय केलेला असेल आणि त्या फोर्सला जर आपण रेजिस्ट केलं म्हणजे काय केलं, कुठलंच डिफॉर्मेशन न होता जर आपण त्या बॉडीला जर रेजिस्ट केला असेल तो फोर्स, तर सांगू शकतो की आपण द मटेरियल इज हॅव्हिंग द मॅक्सिमम स्ट्रेंथ. इफ आय विल अप्लाय द लोड अँड इमिडिएटली डिफॉर्मेशन विल बी टेकिंग प्लेस, cannot say that the strength is high. If it will resist the deformation or it will resist the applied force, then we can say that the strength of material is very very high. Okay, so that definition just now we have discussed. Now we have to go for the basic difference between the what is mean by the applied mechanics and what is mean by the strength of material. So what is the basic difference between them? Applied mechanics. In applied mechanics also we have studied so many concepts, we have solved so many problems related to the mechanical structure, related to the civil structure. In SOM or in MOM also again we are studying, but there is a basic difference between them. If you go through the applied mechanics definition first, applied mechanics, study of external forces applied on the rigid body. So this word is very very important. Study of external forces applied on the rigid body. So body is considered as a rigid, and on that particular rigid body the external forces are applied. Rigid body means we know the rigid body. For example, here I will draw one body and that body is rigid. Rigid means it is fixed from all sides. Let's take example like that. This hatching line indicates rigid side. So this is the rigid body, and on that particular rigid body, suppose if any force is applied, some p amount of force is applied. Okay, so this body will be considered as a rigid body, and on that particular rigid body this external p amount of force is applied, and if we have to study this effect of P on this particular rigid body, it will becomes under the category of applied mechanics. So here important body will be considered as a rigid body. Rigid means it is totally fixed from all sides. Even the P amount of force is applied, and if there is a deformation, we can consider this deformation as negligible or is equal to zero. Because why? Body is considered as a rigid. जर बॉडी तुमची रिजिडच असेल तर त्या बॉडीचं कुठल्याच प्रकारचं डिफॉर्मेशन आपण एक्सेप्ट करू शकत नाही. So that study we have to do in the applied mechanics. But in case of a MOM, mechanics of material, in case of a SOM, strength of material, or in case of a analysis of mechanical element, if you go through the definition, let's see. Study of internal effects produced in elastic body due to external force. Now here two words are very important: elastic body, and one another is the internal effects produced. In applied mechanics, external force is applied. In SOM, here also external force is applied, but basic difference between applied mechanics and strength of material is related to the body. In applied mechanics, body will be considered as a rigid body which is fixed from all sides, but in case of a SOM, the body will be considered as a elastic body. So what is the basic difference between rigid and elastic? Rigid means it is totally fixed from all sides, or maybe in the direction of force, but elastic means it is the property of elasticity. Elasticity means if the force is applied on the body, deformation is taking place, then we can say that this body is elastic. And if the force is removed, body regain to its original position, that body will become under the category of elastic body. You know about one property of the material, elasticity. What is the property of elasticity? If the force is applied on elastic body, the deformation is taking place. If force is removed, body regain to its original position. That property is called as a elasticity, and such types of the elastic bodies are considered in case of a MOM or in case of a SOM. So the study of internal effects produced. Let us see. This is one body. Okay, elastic body we can consider. This is the force applied. One force is applied at the left side, another force is applied at the right side. According to this direction, I can say that this is a tensile force. I can write it as a capital T. Okay, this body will be considered as an elastic body. Okay, so if this T tensile, if the tensile force is applied on this particular elastic body, what is the internal effects produced inside? That study we have to perform in the strength of material. बघा, ही जर बॉडीवर फोर्स अप्लाय केला तर या बॉडीचं असं डिफॉर्मेशन होणार. Its length is goes on increasing. Why length is increases? Because their internal structure it will get changed due to the external force. What happened? Due to the force applied on that particular body, its internal structure it will get changed, and due to that internal structure change or due to the change in internal effects, the length of body is increases. And we have to study that particular part, means we have to study the strength of material. In the applied mechanics, if you go through the figure, the body is fixed from all sides. If force P is applied, there is no any chance for the deformation because the body is fixed from the all sides. जरी त्याच्यामध्ये डिफॉर्मेशन होत असेल तरी आपण ते डिफॉर्मेशन एक्सेप्ट करू शकत नाही, बिकॉज वी हॅव मेड वन अजम्पशन दॅट इज बॉडी इज टोटली rigid. Therefore, deformation will not be accepted in the applied mechanics. But in case of a strength of material, the body itself considered as a elastic. Due to their elasticity property, due to the external forces applied on the elastic body, its internal effects, its internal structure, it will get changed. And due to the change in internal structure, sometime length of bodies increases, sometime length of bodies decreases. It depends upon the type of loading. जर टेन्साइल लोड अप्लाय केला असेल, ऑब्विसली बॉडीची लेंथ इन्क्रीज होणार आहे आणि त्याच्यामध्ये तुमचा टेन्साइल स्ट्रेस डेव्हलप होणार आहे. एक्झॅक्टली अपोजिट, इफ कॉम्प्रेसिव्ह फोर्स इज अप्लाइड, obviously the length of bodies goes on decreasing and compressive stress will be developed. So here the structure of that particular body it will get changed. Why? Because some internal effects are produced in the elastic body due to external force. अप्लाइड मेकॅनिक्स मध्ये पण आपण एक्सटर्नल फोर्स अप्लाय करतोय, सॉम मध्ये पण आपण एक्सटर्नल फोर्स अप्लाय करतोय, बट ड्यू टू द बॉडी डिफरन्स हियर internal effects are produced. In applied mechanics, deformation is totally zero because body will be the rigid. In strength of material or in mechanics of material, due to the external force, some internal changes are happened, and due to that only the deformation of body is taking place. Means length is increases or length is decreases, and this is possible only in the इलेस्टिक बॉडी. बघा, एखाद्या बॉडीचं जर डिफॉर्मेशन और एखाद्या बॉडीचं जर आपल्याला स्ट्रेंथ मेजर करायची असेल, जर त्या बॉडीज काही डिफॉर्मेशनच होत नसेल तर आपण कुठला पॅरामीटर मेजर करायचा सांगा. इफ फॉर एक्झाम्पल 10 kilonewton force is applied and for that 10 kilonewton there is a zero deformation. If deformation is zero, stress is zero, strain is zero. If I will increase the load up to the 100 kilonewton, then also deformation is not taking place. Length is not increases or length is not decreases. If length is not increases, length is not decreases, there is no any development of stress, there is no any development of strain. Why such types of the situations are there? Because there is no any internal changes in that particular body. If internal changes are not happening, then it is not possible to check the strength of material, or it is not possible to check its deformation or number of stresses developed in that particular body. जर त्या बॉडीचं काहीतरी डिफॉर्मेशन होत असेल, ते डिफॉर्मेशन झाल्यामुळं आपण त्याची चेंज इन लेंथ काढू शकतोय, त्याच्यामध्ये इंड्यूस झालेले स्ट्रेसेस जर आपण फाइंड आउट करू शकत असेल, तरच आपण त्या बॉडीची स्ट्रेंथ आपण मेजर करू शकतो. अँड दॅट वी हॅव टू स्टडी इन अवर सब्जेक्ट, दॅट इज मेकॅनिक्स ऑफ मटेरियल or the strength of material. Therefore, these two definitions are very important to understood. That is, study of external forces applied on a rigid body, it will become under the category of applied mechanics, and study of internal effects produced in elastic body due to एक्सटर्नल फोर्स. म्हणजे दोन्ही बाजूमध्ये एक्सटर्नल फोर्स तर आहेच, पण बॉडीचा डिफरन्स असल्यामुळे आपण कुठला पॅरामीटर कुठं काढू शकत नाही आणि कुठं काढू शकतो, दॅट वी हॅव टू अंडरस्टँड फ्रॉम दिस पर्टिक्युलर two subjects, that is applied mechanics and the mechanics of material. Okay, then if you take the example of beam, in case of strength of material, on the beam, if I will apply the point load, if I will apply the UDL, if I will apply the UBL, then also there is no any change in the beam. How it is possible to find out the critical points? Whether it is possible to find out its shear force, whether it is possible to find out its maximum bending moment? No, because there is no any movement of the beam. Means we can say that that beam is rigid. But if load is applied and bending of the beam is taking place, that beam will be converted from rigid body to the elastic body. Why? Because due to the external force, the deformation is taking place. Therefore, that beam will becomes under the category of elastic body. Therefore, in case of a strength of material, whatever bodies, whatever components we are using for the analysis, all the such types of the components will be considered as a elastic body. Maybe in the chapter number 1, whatever circular bodies are there, rectangular bodies are there, square bodies are there, all the body will be considered as a elastic. Strain energy, in the second chapter, spring is there. बघा, स्प्रिंग वर आपण फोर्स अप्लाय केला तर स्प्रिंग कॉम्प्रेस होते. कॉम्प्रेस होते म्हणजे काय होते, बॉडीचा ओरिजिनल साइज अँड शेप काय होतोय तुमचा चेंज होते. मीन्स अगेन दॅट बॉडी विल बिकम्स अंडर द कॅटेगरी ऑफ इलास्टिक बॉडी. थर्ड चॅप्टर, प्रिन्सिपल स्ट्रेसेस. ऑब्विसली स्ट्रेसेस कॅल्क्युलेट करतोय म्हणजे आपण बॉडीचं डिफॉर्मेशन होतच असणार आहे. लास्ट चॅप्टर, फोर्थ चॅप्टर, टॉर्शन. शाफ्ट इज ट्विस्टेड, you will get some angle, twisting angle, means the movement of shaft is taking place, means that shaft is also come under the category of elastic body. It is not a rigid body. And remaining section 2, it is totally based on the beam only. If the forces are applied, bending will be taking place, then and then only we can calculate the bending stresses, then and then only we can calculate the shear forces, then and then only we can calculate the slope, deflection. डिफ्लेक्शन बघा, किती जरी फोर्सेस अप्लाय केले तर बीम खालच्या बाजूला डिफ्लेक्टच होत नाही. मीन्स दॅट बीम इज टोटली रिजिड इन कन्स्ट्रक्शन. जर डिफॉर्मेशन खालच्या बाजूला होत असेल तरच आपण त्याचं काय करू शकतो, डिफ्लेक्शन मेजर करू शकतो. देअरफॉर व्हॉट एव्हर द 8 chapters are there, in that 8 chapters, whatever bodies we are considering, all those bodies will become under the category of elastic body. Okay. Then second, every material should have adequate amount of strength. This is the requirement. whatever material we are developing in the industry, what is our requirement? Every material should be strong enough. प्रत्येक मटेरियलनं त्याचं ऍप्लिकेशन परफॉर्म केलं पाहिजे. If that components are breaking continuously, they are not sustaining the loads, we can say that that material is not having that much amount of strength. So what is our requirement? We have to make that particular material strong enough as per the requirement. If you have manufactured the material to sustain the load up to the 80 kilonewton, so below 80, he can sustain any load, but you have manufactured the component for 80 kilonewton load and your component is breaking for 70 kilonewton only. So what is the use of that particular component? He is not sustaining 80 kilonewton, he is breaking at 70 kilonewton only. So there is no use of that particular component for further application. Okay. So this is the requirement. So every material should have adequate amount of strength, maximum amount of strength. So that material can perform their application प्रॉपरली. जेवढ्या लोडसाठी ते मटेरियल आपण डिझाईन केलेलं आहे ऍटलिस्ट तेवढा तरी लोड त्या मटेरियलला काय केला पाहिजे, सस्टेन केला पाहिजे. तर त्याच्या लिमिटच्या आतच तुमचं मटेरियल जर ब्रेक होत असेल तर त्या मटेरियलचा आपण काहीच यूज म्हणू शकत नाही. ठीक आहे, वी हॅव मॅन्युफॅक्चर फॉर 80 किलोन्यूटन अँड फॉर 85 इट इज ब्रेकिंग, नो प्रॉब्लेम. He has performed our application. He has satisfied our requirement up to 80 kilonewton. He has to sustain. He has sustained. We have increased the load up to the 85 kilonewton, so that material will get break because the load is increases beyond the limit, that is 80 kilonewton. Therefore, every material should have adequate amount of strength. And once again, there is a definition. Strength is the ability of material to resist the applied forces without deformation, or resistance to deformation is called as the strength of material. This particular definition is very, very important for your aptitude test. So many times the questions are based on this particular strength of material. Some wording will be given and some options will be given at that time. Many students are unable to remind this particular definition. So simple definition is there for the strength of material: resistance to the deformation or resistance to the applied forces without deformation is called as a strength of the material. And this particular strength we have to check only for the elastic bodies. Elastic bodies in the sense force applied, body change its original position, force removed, body regained to its original position. You can take the example of rubber. If I will apply the load on the rubber, its length is increases. At certain point, if I will reduce the load, that rubber comes to its original position. But sometimes, if that load is increases beyond the limit, लोड जर त्या प्रमाणाच्या बाहेर जर गेला आणि जरी आपण फोर्स रिमूव्ह केला तरी पण काही वेळा ती बॉडी ओरिजिनल पोझिशनला येत नाही. व्हाय? वी हॅव क्रॉस्ड देअर इलॅस्टिक लिमिट. एकदा का त्या बॉडीनं तिचं इलॅस्टिक लिमिट क्रॉस केलं आणि जरी तुम्ही फोर्स रिमूव्ह केला तरी पण ती बॉडी ओरिजिनल पोझिशनला येत नाही. इलॅस्टिक पॉइंटच्या आतमध्ये जेवढ्यापर्यंत तुम्ही फोर्स रिमूव्ह कराल तेवढ्यापर्यंत ती बॉडी तुमची माघारी येईल. Therefore, in the chapter number 1, we have to study the stress strain diagram for the ductile material. In case of a ductile material, there are 2 points are there: proportional limit, elastic limit. Beyond elastic limit point च्या आत जर तुम्ही फोर्स रिमूव्ह केला तर बॉडी ओरिजिनल पोझिशनला येऊ शकते. But if that material crosses their elastic limit point, and that time if you remove that particular load, body does not regain to its original position. It will remain as it is in the deformed condition. So that elastic point is very, very important, and that elastic bodies we have to study in this particular subject, that is strength of material. Instead of saying the SOM, I am using the word mechanics of material. So strength of material and mechanics of material and analysis of mechanical element, all the three names, all the three subjects are correlated with each other. So this is about the basic difference between the applied mechanics and the strength of the material. So now, before moving to the next part, anybody is having the problem to understand the basic difference between AM, applied mechanics, and the strength of material? If you have any problem, please unmute from your side and ask me the questions, or you can ask the question in the chat box. Any problem?
No.
So everyone has understood? Near about 30, near about in between 30 students have already joined. If you are facing problem to understand any concept, please at that time only you ask me. I will repeat the things once again. In this particular subject, these are all the basic things. These basic things are very important for your aptitude test or for your interviews. These all are the basic questions. These are the basic differences in your aptitude test or in your interview. No one is asking you to solve that particular numerical, to solve that big numericals. Only they are interested to understand the basic things or your knowledge. Therefore, these are the basic things we have to understood. So I hope everyone has understood. There is no any problem. So if there is no any problem, can we move to the next? Hmm?
Yes, sir.
Yes, sir.
You can chat in the chat box also, no problem. Just wait a minute. Okay. So there is no problem, I think, for your understanding. Okay. Now, just now we have discussed these types of testing, which type of testing, how the testing will be conducted, which are the machineries are used for testing. So now we will discuss about the types of testing, which are the basic testings we have to perform in that particular material. Because in the chapter number 1, maybe in the chapter number 4, torsion is there, chapter number 1 testing is there, then remaining second section is related to the beam, how the testing will be conducted, and which types of machineries we have to use for the such types of the testing. Maybe you have performed in your diploma. I don't know whether you are having the practicals in one of the subject, or maybe in the that one subject is there, measurement and metrology. In that, whether the testing is there or not, I don't know. But if that machine is available in your college, maybe you know about the universal testing machine. Universal testing machine, in short form we can call it as a UTM. So universal testing machine. So these types of the machineries are available in the laboratories or in the colleges for the testing of the components. So through this particular universal testing, we can go for the three different types of testings. One is a tensile test. If we have to go for the tensile testing, then this UTM will be used. If we have to go for the compressive testing, then same machinery can be used. If we have to go for the bending testing, at that time this particular machine will be used. So this is the basic structure of that particular machine. So if you go through this particular figure, so this is the base side, okay. Then whatever the at the center point, one specimen is there. So this is the vertical specimen, okay. It is fixed between the two grips, okay. This is the bottom grip which is fixed. This is the holding grip, you can see here. In between these two particular grips, your component is fixed, okay. So if you go through this particular grips or the holes at the bottom side, this bottom grip is totally fixed, it is not movable. But whatever this top grip is there, it is movable through this particular lead screws. So here at the top side, this is the load cell. What is the use of load cell? What is the use of that particular load cell? In order to measure the load. The name itself suggests load cell. The basic function of the load cell is to measure the how much amount of load is applied on that particular body. Okay, so this particular load cell, this particular top grip, these are movable. So this left side, this is the lead screw. This is again right side lead screw. If you check, जर तुम्ही आपल्या व्हेकलचा जॅक जर बघितला असेल, if I will rotate that particular downward component, that lead screw is moving in upward direction, and due to that the vehicle is also moving in the upward direction. But in that particular screw jack, we are doing the manual operation. आपल्याला मॅन्युअली ते काय करावं लागतं, रोटेट करावं लागतं. त्याच्याप्रमाणे तो लीड स्क्रू वर जातो आणि आपली व्हेकल काय होते, वरच्या डायरेक्शन मध्ये जाते. तसंच सिमिलरली here these are the lead screws are there. This is the load cell. On that particular load cell, this particular grip is top grip is connected, and this is the automatically moving. So to that particular machines, some buttons are given. If that buttons I will press, this particular component, this particular holding, it is moving in the this particular is moving in the upward direction. So this part, it will be moving in upward direction. Sometimes it will be moving in the downward direction. So this is the movable part, which will be movable through the automatic machines. Okay. So this load cell is connected to this particular grip, and this grip is connected to that particular specimen. Now here, if I have to perform the testing, now why we have to perform this particular testing? For example, tensile test. If you have manufactured one bar, that bar may be square bar, rectangular, or it may be the circular. You have changed their chemical structure, you have added some other components, and you have manufactured the new bar. And we have to use that particular bar in any application. For example, I have to use that particular bar or rod in one of the machine or in one of the vehicle. But initially, before the application, I have to go for its tensile testing. So for that purpose, if I have to go for its tensile testing, I have to use the such types of machinery. So by using the UTM, universal testing machine, I can go for the testing of tensile, then compressive, and then for the bending. So simply that specimen I have to hold in between these two grips. The bottom grips is totally fixed. This top grip is movable. It will be moved in upward direction. Sometimes it will be moving downward direction. The specimen is fixed in between them. If this grip, this top grip, if it is moving in the upward direction, there may be tension in this particular spring, because bottom grip is totally fixed. जर ही ग्रिप जर वरच्या बाजूला जर मूव्ह व्हायला लागली, तर ह्या स्पेसिमन मध्ये काय होणार आहे, तुमचं टेन्शन क्रिएट होणार आहे. And due to that tension, what happen here, how much amount of load is applied, that load cell will be given directly on the display. So this particular load cell is connected to this particular grip, and that grip is already connected with the specimen, and that load cell is directly connected to your display unit. If I will start the load from 10 kilonewton, so initially this load cell will give the reading 10 kilonewton. It will be displayed on that particular display. If this grip, upper grip, is moving in upward direction along with this particular lead screw, the load is increases from 10 to 20, 20, 30, 40, 50, 60, like that. This load cell will give the increasing value, and at one point this particular specimen will get break at this particular center point. एका ठराविक लिमिटचे जर आपण बाहेर गेलं, तर हा स्पेसिमन तुमच्या सेंटरला कुठे तर काय होणार आहे, ब्रेक होणार आहे. मीन्स यू विल गेट इट्स ब्रेकिंग पॉइंट. म्हणजे तुम्ही 10, 20, 30, 40, 40, 50, 60, 70, 80 kilonewton, it is the breaking point. Means this particular new specimen can sustain the load up to 80 kilonewton only. Means you will get the breaking point. 80च्या वर जर त्या बॉडीवर जर लोड अप्लाय केला, तर तो कंपाऊंड तुमचा ब्रेक होतोय, असं त्या ठिकाणी तुम्हाला काय होतंय, analysis होते. So this particular testing will be considered as a tensile testing. Means we are calculating the breaking point. Or simultaneously we can calculate the tensile stresses. कारण जर आपल्याला जर tensile force जर मिळत असेल आणि ह्या बारचा जर क्रॉस सेक्शनल एरिया माहित असेल, तर easily we can calculate the tensile stress developed in that particular component. So this is the one type of testing, that is tensile testing, or UTM machine is available to perform the such types of the testing. In the industries, such types of the so many machines are available, but that machines are having their unit value. Some machines can sustain the load or apply the load up to the 10 ton, 20 ton, 50 ton, 100 ton. Each and every material machines are having their limit. So based on that particular limits, we can perform the various types of the testing. Okay, then this is the bending testing. So if you go through this particular bending, so simply if you go through the structure, bending testing means we have to calculate the bending moment, or sometimes we have to calculate the bending stresses. Okay, so here some support pins are given. So this yellow color represents your specimen is there. So this left side, one supporting pin is there. At right side, another supporting pin is there, and on this particular supporting pin, this specimen is hold. It is like a cantilever. It's like a cantilever. At one side, one support is there. At another side, one more support is there. And at this particular center point, the force is applied. Okay, so due to the force is applied in the downward direction, so this particular component, it will get bent in the downward direction because the force is applied from the top side, and the bending of the specimen, it will be taking place in the downward direction, and through this particular bending we can go for calculation of its bending moment, or if the bending moment I can calculate, I can also calculate the bending stress induced in this particular specimen. So such types of the bending testing is also going to carry out by using this particular UTM machine. This bending also we can perform by using the same UTM machine, because here at the bottom side we can fix one support pin, here at another side we can fix our support pin, and on this particular pins I can hold our specimen. This holding grips bottom side, it will be removable. It is the one attachment. हे attachment आपण रिमूव्ह पण करू शकतो काही वेळा त्या ठिकाणी अटॅच पण करू शकतो. आणि ह्या वरच्या ग्रिपनं जर आपण हिचं जर असा फोर्स अप्लाय केला तर this will be considered your bending testing. That means simultaneously by using the single machine only we can perform its tensile testing, we can perform its compressive testing, or as per requirement we can perform its bending testing. So this is a one common machine which is used in all the types of industries to perform the such types of the testing, and this is the example just now I have given, that is the bending testing of the material. So such types of the attachment, such types of the accessories are given with that particular machines. Only we have to add them and we have to perform the required testing. Okay, so this is about bending, compressive, tensile testing we have discussed. Now the very important machine is related to the torsion testing of the material. So torsion means we have to find out the torque induced. Sometimes we have to calculate the shear stress induced. Sometimes we have to calculate the twisting moment. Twisting moment, it is always calculated in degree. That means by how much amount of angle the shaft get twisted, that we have to calculate. So here whatever the machine is in front of you, its structure is similar to your lathe machine. बघा ह्याचं स्ट्रक्चर जर तुम्ही बघितलं तर इट इज लाईक ए lathe machine, but in case of a lathe machine, at left side only one chuck is there where we can hold that particular job, but here we have to perform the torsion testing. So one more chuck is given at the right side to hold the component. बघा, if shaft is rotating, it is rotating in one direction, तर आपल्याला त्याच्यामध्ये ट्विस्टिंग मोमेंट जर क्रिएट करायचा असेल तर at one side we have to twist that particular shaft in clockwise direction, at another side we have to twist that particular shaft in anti-clockwise direction. That means at the left side clockwise, at the right side anti-clockwise, then and then only twisting is possible. तर दोन्ही बाजूला जर आपण क्लॉकवाइज फिरवायला लागलो किंवा अँटी क्लॉकवाइज फिरवायला लागलो तर त्या ठिकाणी ट्विस्टिंग मोमेंट जनरेट होणार nahi. So in order to generate the twisting moment, so what we have to do, we have to hold our component in between these two chucks like this. Here I will draw the figure like that. You have to fix our component in between these two chucks, and once that machine will get start, it will create the twisting moment. So here in the bottom figure, if you go through the figure number 1, here at another side it is rotate in this direction, at its right side it will be rotate in this particular direction, and once the twisting will get started, so at the center point so at the center point there is a nick formation. आता nick formation म्हणजे काय बघा, आपण जर एखादी गोष्ट जास्त पिरगाळत गेलो तर सेंटर पॉइंटला तिथलं मटेरियल पिरगाळत तिथलं मटेरियल काय होतं, रिमूव्ह होतं, and at certain point that material will get break at the center point. So this is the figure number 1 which represent the condition number 1, that is before the twisting moment. But in the second figure, if the maximum twisting will be taking place, that shaft it will get break at this particular center point, and through this you will get the how much amount of shaft it will get twisted. So in order to find the twisting moment, or sometimes if we have to calculate the torque, so this is the torsion testing machine. It is also available in the industries, or sometimes it is also available in the colleges to perform the such types of the testing. Now why this particular testing, why that shaft cannot be tested by the tensile machine? Because in the shaft which important parameters are there? Tensile stress is not important, compressive stress is not important in the shaft. important parameter is that we have to find out its twisting moment. We have to find out its torque, amount of torque induced. Therefore, this is the especially this torsion machine is developed for the such types of the shaft टेस्टिंग. कारण शाफ्ट मधला आपल्याला टेन्साइल स्ट्रेस काढून आणि कॉम्प्रेसिव्ह स्ट्रेस काढून आपल्याला त्याचा काहीच उपयोग होणार नाही. Only we have to go for the torsion testing, twisting moment, shear stresses, like that parameters we have to calculate. Therefore, such types of the torsion machines are to be used, and their angle of twist will be calculated like that. For example, if this is the shaft, this is the original condition. After the twisting, sometimes you will get the angle like that. So this much amount of twisting will be taking place. So the angle between this will be considered as a theta. So why this particular from this point to this point, your material will get moved. Why? Because the twisting is taking place in that particular shaft. There from this point to this point, the movement will be taking place. And this is one of the type of angle. Okay, this is one of the type of angle, and this angle we have to measure, means we have to measure its twisting moment. Okay, so this is about the torsion testing. So such types of the machines are also available for testing of the shaft. And now these are the different types of loads which we have to study in our subject. ह्याच्या व्यतिरिक्त आपल्याला दुसरा कुठल्याच प्रकारचा लोड आपल्याला ह्या मेकॅनिक्स ऑफ मटेरियल मध्ये आपल्याला स्टडी करायचा नाही. सो आय होप दॅट एनिमेशन इज ऑल्सो विजिबल टू यू. Whether that animation is visible to all, whatever the movements are taking place in the body, whether that animations are visible. Anyone please reply.
Yes sir.
Yes sir.
Okay, so
Yes sir.
So whatever the figure is in front of you, so at the top side the type of loading is given, and at the bottom side its movement is given. So these are the only 6 figures or the 6 types of loads which we have to study in all the 8 chapters. So in the figure number 1, if you go through its name, tension, how the tensile is developed, you can see one vertical body is there, one load is applied at the top side, another load is applied at the bottom side. Both forces are opposite in direction. One force is moving in upward side, opposite force is moving in downward direction. Due to the tensile, how the length of bodies increases, we can observe through this particular figure. How the length of bodies changes due to the tensile, length is increases. That means this is comes under the tension. Then second figure, compression. Again, the 2 forces are applied. The bottom force is moving in downward direction. Sorry, top force is moving in downward direction. Bottom force is moving in upward direction. Due to the direction of forces, length is decreases. You can see before application of force, length is high, but after the application of force, length is goes on decreasing. That means compressive. So such types of the forces we have to study. Here in the figure number 1, we can calculate the tensile stresses, increase in length, tensile strain. In the second figure, we can calculate the compressive stresses, decrease in length. That means delta L, किती length change झाली किंवा किती length decrease झाली, and compressive strain. Then third figure is related to the shear. The difference between the first 2 figures and the third figure. First figure, the applied force is perpendicular to the cross-sectional area. See, at the top side, this is the cross-sectional area. ह्या figure मध्ये पण आहे, ह्या figure मध्ये पण आहे, आणि ह्या figure मध्ये पण आहे. But in the first 2 figures, whatever that arrows are there at the top side or at the bottom side, these arrows indicates the direction of force, and this direction of force is perpendicular to this particular cross sectional area. जो काय वरचा horizontal surface आहे, त्या horizontal surface ला ते दोन्ही arrow कसे आहेत, perpendicular आहेत. Means the tensile force and compressive force are always perpendicular to the cross sectional areas. But if you observe the figure number 3, in case of a shearing, if you see at the top side as well as at the bottom side, if you go through the direction of force, this force is totally horizontal. Here the force is horizontal, here force is horizontal, and this horizontal force is parallel to the cross sectional area. बघा, हा horizontal force हा वरच्या सरफेसला कसा आहे तर पॅरलल आहे. का, जर तुम्हाला शेअरिंग ऍक्शन जर जनरेट करायचे असेल, बघा 2 जर हात एकमेकावर जर आपण घासले तर दॅट विल बी कन्सिडर ऍज ए शेअरिंग ऍक्शन. म्हणजे वरचा हात हा खालच्या हाताला पॅरलल आहे, म्हणजे वरच्या हाताने आपण जो काही फोर्स अप्लाय करतोय, इट विल बी पॅरलल टू द बॉटम हँड. if I will apply the force by using the bottom hand, that direction is parallel to the top hand. That means both the forces are parallel to the cross-sectional area. If any force is parallel to the any cross-sectional area, that force will be considered as a shear force. And from the first three figures, we can observe the difference. In the first two figures, for both the figures, direction of force is perpendicular to the cross-sectional area, but in case of a third figure, the direction of force is parallel to the cross-sectional area. बघा त्याच्यामध्ये शेअरिंग झाल्यामुळं दोन्ही बॉडी एकमेकाला काय होते, शेअर होते. त्या सेंटर पॉइंटला तुम्हाला दिसतंय बोथ द बॉडीज आर शेअरिंग ऍट द सेंटर पॉइंट, त्यामुळे एकमेकाला घासल्या जाते. Therefore, both the forces are parallel to the cross-sectional area. Then, in the fourth figure, torsion, twisting moment. बघा काय होतंय, twisting moment at the center point. The twisting is happening at the top side. It is rotating in this direction. At the bottom side, it is rotating in that direction. That means top direction and bottom direction both are opposite to each other. At the top side, it is rotating clockwise direction. This is clockwise. At the bottom side, this is anti-clockwise. So due to which at the center point there is a twisting. हा जो अँगल आपल्याला मिळतोय बघा ह्याच्यामध्ये, हा जो अँगल तिरका अँगल जो मिळतोय, that angle we have to calculate, means we have to calculate the twisting movement of that particular shaft, and it is possible only in the shaft because maximum twisting will be taking place in the circular sections only. Some of the rectangular sections are also there, but maximum it will be taking place in the rotating shafts only. So here also we can observe in the figure number 4 how the twisting will be taking place due to the top and bottom twisting, and the center point how the twisting will be happen. So that twisting we have to calculate. Then the fifth figure, bending. Here you can see bending means at the left side it is supported like a cantilever beam, and at the top side the force is applied, and that beam is going to bend in the left side. That means force is applied from the right side and the bending will be taking place at the left side. This figure मी तुम्हाला कसं बोलले होते की horizontal beam काढला होता. It is supported like a simply supported beam, and from the top side the load is applied, and due to that applied load at the bottom side the bending will be taking place. Here only they have changed the structure. The beam will be considered as a vertical. At the left side it is supported, and at the right side the force is applied. So due to that bending, the bending moment is created and the bending stress is developed, and due to that bending we have to calculate the bending stress. So this is about bending. And last figure is related to the buckling. Always keep in mind, in case of a beam, the bending of beam is taking place. Because in case of a civil structure, two important elements are there. Horizontal structure will be considered as a beam, and vertical structure which is used for the supports, ज्याला आपण column म्हणतो, it will be vertical structure. So in case of a beam there is a always bending due to the application of load, but in case of a column there is a always buckling. बघा column it is always vertical in structure. त्या कॉलमला जर आपण वरच्या बाजूने एक लोड अप्लाय केला आणि खालच्या बाजूला आपण लोड अप्लाय केला तर त्याचं जे काय बेंडिंग होतं त्याला आपण बेंडिंग म्हणू शकत नाही, तर त्याला आपण काय म्हणतो तर बकलिंग ऑफ कॉलम. यू कॅन सी बिफोर application of load column is perfectly straight. After application of load it will get bent to its left side. Sometimes it will get bend or it will get buckle at the right side also. It depends upon that quantity of that particular load. So there is a basic difference between the bending and the buckling. First basic difference is that bending is taking place in case of a horizontal structure, or we can call it as a beam, but the buckling will be taking place in case of a vertical structure, or we can call it as a column. So this ड्यू टू द ऍप्लिकेशन ऑफ लोड, बघा कॉलमवर पण एक प्रकारचा लोड असतो, जसं बीम सपोर्ट केलेला असेल तसं ह्या कॉलमवर त्या बीमचा सपोर्ट आहे, परत वरच्या बिल्डिंगचा पण लोड त्या पूर्णपणे कॉलमवर येतो. सो दॅट buckling of the column is also taking place, and that parameter also we have to calculate. But this buckling of column, now that chapter is not in your syllabus. In previous old syllabus, that buckling of column, the separate chapter is there for your study, chapter number 8. But now that buckling of column, it will get removed, and your bending stresses and the shear stresses, both chapters will get separated. Initially they are combined, and this buckling of column is your 8th chapter. but now it is removed from the syllabus because that chapter is not that much important for your further study as compared to the bending. Therefore, only related to the beam only it is there in your syllabus, and this buckling of column it is removed from your syllabus. But just for your better understanding how the buckling of column is taking place and how to calculate its parameter. Now in this particular buckling of column, we have to calculate the two important parameters. One is buckling and another is the equivalent length. So what happened? Before application of load, the column is perfectly straight, vertical. But after application of load, it will get bent like that. Like see here, it will like this. So whatever this buckling is taking place, during that buckling, whether length is increases or whether length is decreases, that parameter we have to check in this particular buckling of column. So before application of load, length will be considered as a capital L, original length of column before application of load. But after application of load, the buckling of column is taking place maybe at the left side or maybe at the right side. तर जे बकलिंग झाल्यानंतर जी काय लेंथ येते, दॅट लेंथ ऑल्सो वी हॅव टू कॅल्क्युलेट अँड दॅट लेंथ इज कॉल्ड ॲज ए इक्विव्हॅलंट लेंथ. मग ओरिजिनल लेंथ आणि इक्विव्हॅलंट लेंथ दोन्हीच्या ह्याच्यामध्ये फरक असतो, अँड दॅट लेंथ वी हॅव टू कॅल्क्युलेट इन दिस पर्टिक्युलर चॅप्टर. सो दिस इज द लास्ट फिगर रिलेटेड टू द buckling of the column. So first 5 figures are very important for your further study. These types of loads we have to consider. बघा, tensile, compressive, shear. These are used in the chapter number 1, chapter number 2, and chapter number 3. First 3 chapters are based on the first 3 conditions. Chapter number 4, torsion, is related to the figure number 4, and second section, all the 4 chapters are related to the figure number 5 only, in which we have to calculate SFD, BMD, bending stresses, shear stresses, slope, and deflection. So this is about the basic natures which you have to understood. So from this particular figure, you can better understood that how the forces are parallel to the cross-sectional areas, how the forces are perpendicular to the cross-sectional areas, and due to the direction of forces, how its movement is taking place, and which parameters we have to calculate, that we have studied today. Okay, so this is about all the basic points we have discussed. So maybe in the next lecture, now because now what happened, the second allotment is displayed in the yesterday. So join with our this particular group. They are taking admission today or tomorrow. So now we are going slowly, and because once again we have to start it from repetition. Maybe some little bit repetition will be there. Maybe for those who have attended first lectures, there may be repetition, but just I will clear all the basic things in within short period, because that students also they have to understood all these particular basic points. Maybe half hour is required to cover that basic things, and once our total division is there, you will get the roll number. We will start with our chapter number 1. That is chapter number 1 is there, simple stresses and the strength. So up till now we have discussed all the important things related to the our subject. Maybe from the starting point we have discussed about the syllabus, then we have discussed about the basic definition of mechanics, each and every word, what is the meaning of that particular each and every word, mechanics, strength, analysis of analysis, material, like that we have discussed. Then we have discussed about the basic difference between the applied mechanics and mechanics of material or the strength of material. Then we have discussed about the type of testing. टेस्टिंग करतोय म्हणजे आपण त्याच्या प्रकारे मशीनी कुठल्या वापरतो, that also we have discussed in the today's lecture. That is UTM is there. Then this is also performed by using the UTM machine. Then we have discussed about the torsion testing of the material, how the what is the basic difference between the tensile testing and the torsion testing, which components are tested by which machines, that also that understanding is also very important to do. And now we have discussed about the types of loadings and their effects on the bodies. We can check through this particular figures. So up to this, anybody is having any problem, please ask me. Can we go with this particular manner? Have you understood what I am telling? You can give me message in the chat box also, no problem. If you are facing any problem, please to ask me. Yes. Yes, Prathamesh.
No, sir, no problem, sir. Understood,
Hmm?
sir.
Have everyone has
100%.
understood whatever I am telling?
Yes, sir, yes, yes.
Yes,
Hmm?
sir.
No. Okay, good. So, with this, I think today we will stop here because further next part we have to start our topic number one only. But we will wait. We will stop today because maybe if our the second lecture is there, maybe in the next Wednesday. Wednesday and Thursday, the two lectures are there. Up to the Wednesday, maybe your division will get finalized. When on that Wednesday's lecture, I will repeat some of the basic things because some new students will be joined our group, and up to that only your division also it will get finalized. You will get the roll number, that roll call list also. Your class coordinator will be sent on your group, and once the roll number will get finalized, all the students will get admitted in our class. Then we will start with some basic points once again, maybe half an hour, and then we will start with the chapter number one. So once I will start the chapter number one, once again I am repeating, don't remain absent. Keep or prepare the separate notebook. Whatever I am displaying here, prepare your notes also. I will give the notes in all respect. Don't worry about the notes for all the subjects. Scanner notes are available with us with proper understanding, with proper figures, with good presentation. All the notes are available. If you refer that notes only, you can score in that particular subject. But requirement is that you have to be ready with your notebook, your pen, and your calculator. Sample 2-3 problems I will solve on this particular slides. But afterwards, if I will give one of the problem for your solutions, you have to solve your problem on in your notebook, and you have to give their answers in the chat box or maybe. So, like procedure we are going to follow, we are going to solve the maximum problems, variety of problems, because each and every problem is very, very important. Some little changes are there in that particular problem. That little changes we have to understood. Initially, we have to understand the statement. Reading of the statement is very, very important thing in this particular mechanics of material subject. If you are unable to understand the statement, and if you are unable to generate the figure from that particular statement, the further calculation part is very difficult to understand. If you are able to generate the figure, if you are able to understand the given data, and if you remind the list of the formulas, all the list of the formulas I will give. If we will start the type number one formula is available in that particular notes. Type number two, type number three, type number four, whatever the number of varieties are there. For each and every variety, I will give the list of the formulas, importance of the each and every formulas, and then only we'll go for the solution of the variety of the problem. So we can take the number of problems. So through that particular problems, we can go for the solution of any type of problem from any type of the book. So like that, we will follow the procedure, and in the next lecture, we will start with our chapter number one. But sometimes in the next lecture, there may be again a repetition of all these particular basic things. So please join the lecture. Your attendance will be considered. Sometimes repetition will be there because new students are joining from the next lecture. Within half an hour, I will clear all the basic things, and then we will start with the uh, chapter number one, that is simple stresses and the stream. So with this, today we will stop here. Now, just for your attendance, I request all the students, please type your name in the chat box. Your name and surname. It will be sufficient. So I request all the students, please type your name in the chat box for your attendance. Rather than this, if you are having any problem, if you have not understood anything, anytime you can call me, you can send me message. I will give the solutions. So I request once again all the students, please write your name at once. It is sufficient, need not required to send the name again and again. At once it will be recorded, no problem. I hope everyone has typed their name in the chat box for their attendance. So with this today, we will stop here. So in the next lecture, we will start with our chapter number 1, that is simple stresses and the simple strain. So don't remain absent. As per the timetable, lectures will be conducted. We are having lectures on Wednesday and the Thursday. In addition to that, if I will get any additional lectures, so at that time, I will take that particular lecture in advance. I will give the message that this lecture will be conducted. So with this, today we will stop here. We will see in the next lecture. So thank you very much for attending the lecture. Thank you.